Good afternoon to everyone. I'm honored to talk about on specific topics in front of such experienced people. But with the theme of this session, I would like to address more holistic way for the whole ecosystem, because e-mobility is part of a ecosystem. A smart grid is part of an ecosystem, and that's what the theme is, that in the smart cities. So how we can attain sustainable, smart and safe mobility. The outline is I'll try to cover, but before that I would like to share a small video why we have these how we reach to these problems. And I am a professor now, so I would cover some current projects which we are working on it as a recommendation with the theme which Dr. Sajid Mubashir has recommended, with the interface to the grid. And as my role is also to give futuristic vision to my students and to the government. And it would not be justified if I would not acknowledge all my students who are working on these projects. You see the whole team sitting over there. So if you want to listen in detail about those projects, anything you want to have interest to commercialize it, feel free to contact them after the session. So one of my students has compiled this video, that how we reach to these problems that we have today. Let's see. It's a clipped version from a TED Talk. Let's see if it's not working here. How we can increase the sound over here. Noise should come from here. Can increase the sound. Yeah, from here. This one.
Yeah. Often moving from place to place in search of food. But about 10,000 years ago, our ancestors began to learn the secrets of selective breeding and early agricultural techniques. For the first time, people could raise food rather than search for it, and this led to the development of semi-permanent villages for the first time in history. The Roman Empire was able to develop infrastructure to overcome these limitations, but other than that, modern cities as we know them didn't really get their start until the Industrial Revolution, when new technology deployed on a mass scale allowed cities to expand and integrate further, establishing police, fire, and sanitation departments, as well as road networks and later electricity distribution. So what is the future of cities? Global population is currently more than 7 billion and is predicted to top out around 10 billion. Power will increasingly come from multiple sources of renewable energy. Instead of single-family homes, more residences will be built vertically. We may see buildings that contain everything that people need for their daily life, as well as smaller, self-sufficient cities focused on local and sustainable production. The future of cities is diverse, malleable, and creative, no longer built around a single industry, but reflecting an increasingly connected and global world.
So if you look at the issues that we have in India, the transportation is always a challenging over here. If you look over this graph, which gives about 5 p.m. the traffic on the roads in different states of the India. So what are the issues? What are the we have traffic, we have pollution, we have crashes, we have weather. So these are the things that we have to address. But how these things come up? What there are reasons behind it, and why we are not able to address them. We are one of the smart population. We are more smarter than China. If you go in industry in any country, if you go to automotive industry, if you go to IT industry, even in US, in Microsoft and big three, Ford, GM and Chrysler, you will find many Indian scientists. In fact, the engineering head of Ford is an Indian origin person. Main cause over here, it's very good to talk, the panel before and now, is corruption that we have prevailing in India. If we do not talk about the corruption, regardless what technology we can bring it, there will be an issue. And then low technical expertise. We have a tendency, we want to go a surface view. We don't want to dive deep. Just want to look at pamphlet knowledge, and we want to do shortcuts. That's never happened. And then definitely rising population, especially in the urban sector, and the system expansion limit, and we want more with less. On one side, the government is talking about competing with China and US and Europe. On the other side, the missions that you have when you talk about budgets, yes, there are no budgets. Yesterday I was at the Innovation Day at Rashtrapati Bhavan. People from 80 universities, they were representing there, and they talk about 4 themes for innovations. That search, spread, sense, and celebrate. Same question asked to the Secretary of the President, what about the budget? If we have innovations, I told them I have so many patents. What can we do? Say, whatever resources you have it, come up with that. So these are real issues that leads to economic issues, social and behavioral issues, and environmental issues. Now, why we need a smart city? Question is, why we are not happy with Delhi? Why we are not happy in Mumbai? Ask our ancestors. They were in those areas, in villages. Going to Delhi, going to Bombay is a big dream. Now we are over here, and yesterday one faculty from Delhi saying, Aligarh is a very calm and nice place. You don't know the life over here. I say, so why we need the smarter cities? Because smart people demand a smart atmosphere to assure them sustainability and safety. And we need a city that can think, come speak. So reality, the smart city is a vision, it's a hype, or it's a reality. So it's up to us. We can talk about the vision, or we can think it's a hype, or we all together can make it as a reality. Reality will happen only, not with only electric mobility, not with only smart grid. It will happen when we'll develop the whole ecosystem, because everything is connected to each other. If one segment is not addressed, the ecosystem will not be able to develop. So these are different aspects, if you can look of a smart city, in which we have a smart living, we have a smart businesses, we have a smart environment, we have a smart mobility, which consists of sustainable, safe, and smart. We need to have smart utilities. We need moral government. We need the e-governance and participation of citizenship. So today I will be focusing more on the smart transportation system based on the theme of this session. This is just an idea how much investment has been done in the transportation and power system in the last decade in the US sector, in the European Union, in Asia Pacific. We can look at it, significant investment has been done in this area. So it would not be wrong to say that these smart cities, we can call them as transport-oriented cities. Yesterday, just coming from Rashtrapati Bhavan all the way here, it took me, believe me, I left at 4 p.m. and I was here at 7 p.m. It took me 3 hours. It took only 1 hour 45 minutes to me to come from Aligarh to Delhi. It took me 3 hours from point A to point B in Delhi. So it will not be wrong to say we need transport-oriented cities, and that's where the role comes of transportation. That's where the role comes from the sustainable mobility. That's where the role comes from the electric mobility that we are visioning, that we are working at the moment to implement in India, which has to be an interactive. It has to have reliability. It has to have a security in there. It has to have remote accessibility and remote management. So different examples we can look at it. But what does the smart mobility means? It should be a self-learning, that the way Mr. Advisor, the IT advisor to Bharatiya Janata Party was talking about it. But the way he said about the innovations, I do not agree with him. If you look at the data on the patents department, we do not have patents. The way patents we have in this area in other countries, unfortunately we do not have those patents. We are not doing innovation. We are trying to do re-engineering. But the re-engineering is not being done properly as well. That's why we are talking, but we need to walk the talk, right? So this self-learning, and we cannot do only one thing. Like Mahindra is doing E2O, it plays a very important role. It's addressing a particular segment of that, but it's not only enough. We have done a study, DHI asked us to do a study because there was a notion that electric vehicles create pollution too, because you charge them from the thermal power plants. So when we did a survey, and we find out very interesting thing, that the major pollution is from buses and trucks and two-wheelers. Cars, passenger cars do not contribute that much to the pollution overall in India. We have considered 4 factors: the carbon monoxide, SOx, NOx, and the carbon dioxide. So these four factors we find out mostly are being contributed by the buses, trucks, and two-wheelers. And then when we took into the refinery pollution, we find out definitely electric vehicle can contribute in reducing the pollution. There is a payback period too, and definitely with the Dr. Sajid Mubashir is saying with the subsidies from the government, there are industries, two-wheeler industries in Bangalore, they are running very good business model for these Flipkart and for delivery two-wheelers, and they are making profit. They have right now, I'm working with one company, they have 18,000 orders just from Domino's for the delivery two-wheelers scooters, and they are unable to meet those orders. So we need smart mobility, which has a programmable, which is connected, which has a smart logistics, and we need a smart charging infrastructure. If you put the charging station and it's not smart, believe me, it's going to be complete failure. You will find a very, very long queue over there. You will find arguments, and it's not going to be done because we are not going to have supercharging stations of Tesla everywhere. We are going to deploy indigenous charging infrastructure over here. So what this is just to give an idea that what are different services which we need for the architecture of transport-oriented cities. We are going to have application module, we are going to have decision, we are going to have process, we are going to have networking, and we are going to have object modules. So what is the motivation? For me, one motivation is for the motherland, and one motivation that we have our Vice Chancellor, Lieutenant General Jamiluddin Shah, who is leading this Green Campus initiative at AMU. So these are the two things that has led to me to start working in this area. I am primarily from my experience in XEVs, but meeting with Dr. Sajid, and he pushed me, and whatever he pushed me, I do it. He asked me to work charging infrastructure, I did it. Now asking me to talk about grid interface, so I will talk only on those projects over here. So these are different parts of the smart charging infrastructure. In summary, governance, economy, and we have environment. And if you look at it, different aspects we have to look at it. Not only the battery, not only the smart grid, but I have to look at the whole ecosystem. And these are different parts, which I cannot talk in this 10 minutes over here, in which we have for EV charging, that I have to, you can look at it in the V of after EV, is grid to vehicle, we have cloud to vehicle, we have X to X, we have vehicle to grid, we have vehicle to cloud, we have vehicle to home, we have vehicle to vehicle, all these aspects I have to look at it. So just giving a holistic view, a high level view, I will cover 7 projects that we are working on it. With Department of Heavy Industry, we are working on 4 projects. One at the home charging, and Dr. Sajid, he was saying, give it India charger name. I don't know why we have so many missions, but all we have English names. Make in India, Startup India. Why come up with an Indian name? So I come up with the Bharat EV charger. To me, looks like all NRIs are just, coming up with this policy. So I gave it name as Bharat EV charger. So that's for the home. And then for the office, little bit faster charging, we can call it level 2 charging. I gave one as the solar-based level 2 charging, and the one regular AC 220 volt charging. And the 4th project that we are working on is DC fast charging, but with a little bit of tweak, with different, we want to make it indigenous. We are not following CHAdeMO or GBT, but we are coming up with a totally different approach, which is very cost-wise so viable in the Indian scenario. So all these 4 projects are in, we have filed patents for it, and it's almost in the final stage where we are developing the prototype. Bharat EV charger, we have already tested it, it's in the testing phase. But here, with the theme which Dr. Sajid has given me, I will cover 7 projects, starting from a very low cost to a vision which we can do in next few years. So first one is this vehicle to home. This basically, this vehicle, if you can see on the left, Omni, we have converted into electric vehicle. It can be charged by solar, or it can be charged by AC, and then this is house one of our professor. And it's except the air condition and the heater, and we are running all the devices with the solar over there. The reason behind this, why I'm calling vehicle to home, in Aligarh or small cities, we have issue of power interruption. And every house has this inverter over there, which they use it, and battery, which they use it for electric vehicle. It costs 3,000 to 4,000 installation cost. So in the night time, this vehicle will come over here, and you can see the picture on the top right. That's basically, it's sitting inside the house. It's a black box. We have made it on the right bottom, that you can connect the vehicle. It will be charging in the daytime with the solar, night time if there is a need from the house. When there is a no power, there's a power interruption, the vehicle will provide the power to the home. And we have designed two modes, reliable mode and the economy mode. So in reliable mode, we are definitely going to, we have made two zones. Reliable mode is going to provide power to the necessary fan, lights, and other things in the house. And in the economy mode is going to provide to all the things except the air conditioning and luxury load. Maruti has showed a lot of interest to make compile as a black box with their upcoming vehicle in 2018, but nothing has been materialized yet. Second one is microgrid to it's basically time constrained microgrid to vehicle XUV charging management, in which we are looking over three aspects, in which we are looking at the XUV charging station, we are looking at the price based controller, and we are looking at the temporal based controller, and how we are taking the data from data acquisition. I will request audience not to take pictures because they are, some of them still in the published stage in my of my parents. So what we are doing over here, we are developing a complete mathematical model of it. And this is connected with the next one which we are talking about. We are looking at the three aspects. When a person wants to charge and he has a smartphone or app that I need to charge, so it will look at three criteria. That what was the minimum time that I can travel to the charging station? What would be the minimum queuing time, and where I can get the minimum power? That's where the role of a smart grid is there, that we are dealing electricity as a commodity. So we have an aggregator, we are looking from that side, and different aspects we are looking at it. So that's how this third one come up, the vehicle to cloud XEV charging management, in which you can see the first one box where the vehicle driver is interacting with the cloud, is interacting with the authorities, is interacting with the global cloud and charging facilities, and also is communicating with the telecommunication or GPS location as well. So this is just the global layout of this vehicle to charging station, where XEV having power transmission with supercharging or the charging smart charging station and with the smart grid. And there is an interface between the distributed cloud and the XEV. This is a high level model that we are working on it, and on the right side you can see these are different constraints that we are working on it. Other thing that offshoot of this, which is a fourth project that come up, is that while vehicle is driving, it has to interact with the where the interaction should start. Maybe a consumer doesn't have a smartphone or doesn't have data service in that road. So we come up, how about our different intersections that we have on the roads, we can make them equipped intersection. And one of our road is called University Road from Babe Sayyed to our center. That's going to be our first test bed over there. So if you look at it today, this intersection you will find which has certain traffic lights over there. You will find certain information that how long the ride will be there. So what we are visioning for an equipped intersection that can help us, it will have vehicle to cloud communication, it will have signal controllers, and it will have GPS enabled. It could have onboard enability to communicate with the onboard charging modules, and even pedestrians are there, they can communicate with their devices. Onboard equipments are there, and then it has the capability to integrate as a vehicle to grid. And right now we are debating how we are going to use the communication channel. It could be Wi-Fi or Bluetooth or 4G, or how many hertz is going to be. The fifth one is a smart battery swapping station. What we have looking at it is not as a separate unit. Dr. Junjunwala has mentioned about the Israel failure, about the battery swapping station. So we are not looking at battery swapping station as a separate. In fact, we are looking battery swapping station as an aid or as a complement or as a supplementary charging facility to the charging infrastructure, in which we have divided into three categories. For the two-wheelers and three-wheelers, we are looking at the kiosk like we have for the petrol pumps. For the cars, we are looking at the car wash like that facility. And for the buses, we are going to have facility at the bus depot. This is just a layout how we are going to have swapping lane, how the robotic arm will bring the batteries from different slots, and how we are going to have a control loom, and how we are going to be communicating with the distribution. That's very important, how we are communicating with the distribution grid. The similar center like CARET, which I was working in Chicago with Dr. Shahidepur, now they have complete battery bank, And what they are doing, that they are charging the batteries in the night, and with the low time period and to maintain the frequency of the grid, they are getting payback. Basically, they are getting paid for charging the batteries. And in the morning time, they are being able to provide the backup power, and they are again earning the money. So the battery swapping station has to communicate with the grid and has to play as an aggregator, and it has to be a profitable solution. So for that, we are also doing detailed analysis so that we can have a certainty for the profit revenue for the XCV aggregators. The last one which we are working on is the dynamic wireless charging. So a lot of people are working on wireless charging. Last year, GE has shown in the auto show. So for the stationary wireless charging, right now we are working on how we can have the complete interface. But for the dynamic wireless charging, where we can have smart cities, over there how we can do the charging management for that. In that we have divide the data acquisition system into primary, secondary, and tertiary level, and how we are going to communicate with the ECUs on the XCV, and how we are going to have this billing will be there, and how we are going to develop the protocol. The seventh one, which will play a very important role in all these projects, would be the big data processing in the transport-oriented cities architecture, in which you can look at it. We have a smart grid, we have microgrid, we are going to have a SCADA-based system, we are going to have IoT-based system, we are going to have metering, we are going to have web, and on the right side you can see all these services will have, you can see the data sources on the left, we have the big data analytics, and then we have the knowledge base, which is going to help in operating vehicle to cloud, vehicle to grid. This is a long time vision, but definitely this will play the basis, as the IT advisor to the BJP has mentioned. This is going to play a very, very key role, and that's how we are going to come up with the complete solution. If we are not going to have this complete big data analytics solution, we are going to have complete chaos on our charging stations, and we will find out there will be a new syndrome, which we call it range anxiety, for all the EV operators. So the path to smart e-mobility will be the analysis of vehicular networks. The social aspects are very important, which are holidays which we have. It's a religious holidays coming up. Some big event are coming up. And then studying the vehicle networks to improve performance. Very important role, how to avoid the accidents. How we can not have the same range anxiety which we have EV operators throughout the globe. Pretty much everyone in US who has EV, he tried to keep one conventional vehicle to is still comfortable to go on long drives, very, very long drives on EVs. Then this one, some vision that how we are going to have connected electric vehicles. This basically the three aspects which we have to look at it: safe, smart, and sustainable, in which we have going to have vehicle to vehicle communication and vehicle to infrastructure communication. We are going to have dynamic mobility applications, and definitely we'd want to have sustainable solution. So these three aspects we have to keep in mind when we are coming up with complete ecosystem. And then what would be the role of public sector? Planning, designing, building, maintaining, and operating. In that, definitely we are going to have in planning stage, we have performance data, we have mode choice, we have public transit ridership, and in building a stage, we are going to maybe have the whole infrastructure, we have to look at it. Today, there is no concept of drivers driving on the Indian road, the concept of the lane. So how much, yesterday my driver couldn't make a turn just because the other driver driving on my right side couldn't let us make a right turn over here. So that has to come up. Then monitoring is very important, and how we can maintain the marking reflectivity, how we can have the roadside equipments, how we are going to have implementation of different devices. And then definitely it has to be predictable. It has to be operatable. So these are different aspects which we can think of when we will have smart cities by 2040, so we can have this vision. In AMU, we are working with one renowned industry. We are working on these connected vehicle projects. And then this is one of the main gate of AMU, and that's what we are planning to have over there. So that's all I have today.